Hello, everyone, and welcome to another community stand-up today with some interesting, crazy C# things we'll talk about. So my name is Immo Landwerth, and today we have Jared Parsons on. Jared, do you want to introduce yourself?
Yeah, hi, I'm Jared Parsons. I'm the C# compiler lead. I've been working in kind of the .NET language space for about like the last 15 years or so, and kind of on .NET production for about the last 7 or 8.
You
And
also
you
do
can
something.
often, I also post all kinds of funny little C# samples on Twitter, kind of poking at little holes and corners in the languages I think we're going to talk about today.
You should definitely mention VS Vim as well, given that.
Yes, I am also the author of the Vim extension for Visual Studio called VSVim, because when you're burnt out working on Visual Studio, you think the best thing you can do with your non-existent free time is write a Vim emulator in F# for Visual Studio.
Things one does. And with us is also Kathleen. Do you want to introduce yourself as well?
Yeah, I'm Kathleen Dollard. I'm a PM for .NET Languages. So that would be C#, Visual Basic, and F#. So today we're going to talk about C#, mostly.
Hopefully.
Well, I mean, we can talk about other things too. We can talk about everything Jared would like to talk about and people would like to ask Jared about. So yeah, and we have Bill Wagner will be helping out in the background. So yeah.
All right, Jared, tell us what you have. What crazy thing did you bring us?
Where do you want to start? Ace has got to be async, right?
Yeah. So one of the things Immo wanted me to talk about stand-up is like if you follow me on Twitter, like I said, you'll see me. I post all these funny little things like this is valid C#, or like here's a challenge, write something in C# that does such and such. And one of the ones I kind of want to start off with, which has tended to be one of the more popular ones over the year, is I kind of posted this little teaser on here called what I call like the true Buffalo version of the async problem, where it basically, this is potentially valid C# code. You can have class var with a method that is async, await async. If those are not familiar, this is kind of a little play on what is called like the Buffalo part of the English language. In the English language, it is Buffalo is a complete grammatically and syntactically valid C# like English sentence.
Can you up your font a little bit on that?
Up my font a little bit. This one
on the Buffalo thing.
Oh yeah, okay, the Buffalo horns.
Yeah, although I guess you kind of get the.
Yeah, it's just basically like you can say buffalo 8 times in a row in English, and that is a valid sentence. It makes sense.
Yeah.
And so kind of like the joke I have is like you can do this in C#. You can actually say async. I think we've got 5 asyncs in a row, and then we got an await and another async, and like you can actually make C# say this. This is valid code that you can compile if you know all the tricks of the language. And so some people ask, like, why can this happen? And there's a lot of different reasons. But the first one is that C# is a language that cares deeply about compatibility. And so one of the big guarantees we have in C# is we want to make the upgrade experience seamless and simple. So as you buy new versions of Visual Studio, you move to new versions of the language. Like we want that to be easy. We want people to not hesitate to do these things. And so we value heavily compatibility. But that also means that as we evolve the language and we add new things to it, we have to keep the old code compiling. And so like async and await is not something that existed in C#1. It is something that came along much later in the language. And so we have to deal with the fact on the compiler team we designed these features that it's completely possible that someone said, if I could spell correctly, someone had written, for instance, class async, and they had a variable. They had essentially, if we have to go all the way back to kind of C# like 1.0, program. Static void main, you have your like typical kind of hello world structure. Like someone could have had a variable called async. If I could actually spell here and not find it helps. So it's like this is something that's completely valid. We have to deal with the fact that async could be a type, which means that async could be, for instance, like a return type.
Hey, Jared, can I talk to you about your font again? Can you get that?
You can bug me about it all you want. There we go. Is this better?
Much better.
Yeah, I'm on a small screen right now, so I'm gonna
Okay.
keep us honest for the folks that are also on smaller screens.
And we have similar problems with basically like await. Await is yet another keyword, and it's something that people could make to be a valid type. And you can even start playing with this. Like, this is code that was completely legal C# 1 code, where someone could have local async await. They could have had await as a return type. And if you got really funny, you could do things like people could basically say async, await async as like a valid method. And this is something we have to contend with when we evolve the language. And the way we do this is that as we add new keywords to the language, they're not real keywords. They are basically what we call contextual keywords. What we do is, as we go forward, we say, hey, we have to deal with the fact that these could have been types. These could have been locals. And the first thing we do is we try to bind them that way. When we're looking at like this method here, and we have basically async await and things like that, like we start by saying, okay, we have to first consider that this is a type. Is there a type called async? Ooh. Hold on, my headphone.
Technical difficulties. Yeah.
This is the moment where we have the 3 color bars. Beep.
Yeah.
Sorry about that. My headphones decided to go nuts there for a second.
All right. Glad to have you back.
Yeah. So we have to, we basically, when the way we evolve these features is we just say, hey, we will start by binding them, as they could have existed before. And if that fails, then we will start treating them as they were C# keywords. So if we like comment out the async here, we'll start getting all these errors saying like, hey, this is like a type. We need to have all this fun stuff. And so I can use that to kind of play with things. And we can get to kind of the first step of the Buffalo problem, where the first step of the Buffalo problem says I had class var there. Now, while var today, most users basically think of var as a way to have implicitly inferred types. They could have been a type in C# 1. People could do public class var, and some people did this for evil. Some people would define class var as a way to stop people from using var in their code base. Very naughty, but people did it. And it's something that is valid code.
We had people like this in our team, in fact.
I wasn't going to assign blame. I was just going to say people generally allowed for this type of nonsense to occur.
I've changed my mind over the years.
Yes.
But I was certainly one of the voices that said we should allow this as a way to block. I'm not sure it was wise, but I did do that, and I'm not going to deny it, especially because there's people in the chat that might remember. So I'll admit it.
Yeah, and so that's one way that's what ends up being a lot of kind of the plays that I have kind of in my Twitter feed is like you can make things that are essentially what people just think of keywords because that's what 99.9% of the uses are. You can play with them and just make them user-defined types and have some fun with them. The other thing we can play with is C# tends to be a very extensible environment. So when we do features like async and await, like yes, like 90% of the time you have a method called task. We're going to do something, and we are going to then await do something. I should probably make that static so it stops. Well, actually, let's stop there. But like 90% of the time, we let you do. 90% of the time, people are using task. But the C# compiler, we don't hard code task. Like we don't say that these features can only work for task. We always try to take a step back and say, like, is this something that people would want to extend? Is this something that people would want to kind of put their own types to in? Would they like to customize the behavior when we do these things? And so async and await is one of the features where we did this. From the very start, we said that basically we customized await. For instance, like we allow you to basically await many different types. The only thing we specify is that rather than the thing you await must be task or task of T, we say that what you await must have what we call the awaiter pattern. It must basically start by saying like the first await I kind of got to get out of a static method here. Let's actually, the static method's kind of getting bothersome. Let's go down here. Let's just be honest about what we're doing here. So what ends up happening is when we await, like I said, we don't look for task or task key. We say, is this thing what we call an awaiter? And the first thing we say is, does this value have a method called getAwaiter? So we can say here, we can say like task getAwaiter. No. And then we'll say, okay, actually, yes, you have awaited this. It does have an awaiter method, but it doesn't implement iNotifyCompletion. It turns out like implementing an awaiter requires a little bit of work, but not too much. And so I have like a little simple example over here where we can do this. So we can basically change this to, if we have basically my awaiter A, we can then say await A here, and everything is going to be, oh no. Oh, sorry. We have to say, and so suddenly now I can basically await var. So we have a class called var. I can await an instance of it because it has a method called getAwaiter, which returns a value that matches what I need here. It has all of my like iNotifyCompletion. This is an awaiter task and everything here. And so already we've had some fun. We now have a class var. It's awaiter. It's great. But getting to the next step of the Buffalo problem, is there's a difference between what we can await and what we can basically have as valid on an async method. For instance, if I tried to basically say that even though I can await this task, like, can I return it? And the answer is no, because similar to when we await something, we look for a particular pattern. When we have something as kind of a returnable task on an async method, it also has to implement a pattern. And that is called our builder pattern. Our builder pattern is a lot more complex. And so rather than trying to like type that all out here, I just have a nice little handy cheat code over here that I'm gonna paste. If you ever want to do like a builder, this is how you do them. By the way, this is not cheating. Like if you actually go and look at like the .NET source code for how we do task, how we do the async method, particularly if you look at how we implemented value task as a feature in a version of .NET Core, you will find we have this lovely builder. It's implemented much more efficiently. It doesn't have a lot of throw nulls in it, but indeed we have this thing. And so now I have this nice little type my task, where I can basically have that as a return of an async method. And so at this point, we kind of have all the ingredients to do the Buffalo problem. The difference is instead of calling it my task, all we have to do is take advantage of what I told you earlier. All of these things we will first try to bind them as types before we bind them as keywords. So I can go to my task here and say, like, let's just call this class async. Then we'll go down here and we'll call this async as well. We will go up here, call my awaiter await. Take advantage of that little trick I told you earlier. And so now we already have async, await this. And with all of that, we can actually start doing the Buffalo problem. Because we can now basically say, I have an async method, which returns the type async, which meets our task pattern. The name of that method is async. We're going to say that the first parameter of this method is the type async. The name of the value is async. And what we will do is then await that async method. And again, this is completely valid, nonsensical C#, where we have taken advantage of kind of three parts of the language. The fact that we are going to always attempt to bind old types as types before we bind them as kind of their new contextual keyword meaning. The fact that await is actually a completely pattern-based feature. It's looking for getAwaiters and the waiter patterns. And that async, we allow flexible return types as long as it meets kind of our task-at patterns we have here. And so here we have 1, 2, 3, 4, 5, 6 asyncs with a little await in the middle. So this is the Buffalo problem in C# in all of its glory.
That is a worthwhile of an applause. I don't know if I want to see this in production, but so one thing you may want to mention is
I'm not even sure that this is actually seriously. I'll say that as the PM, I care about things like hey folks, are we getting carried away with our backwards compatibility story? When you can do things this bad with it.
Yeah. And so, this is, and I think it's like when people see this, and oftentimes they get the response of like, oh my God, like, why did you allow that? Like, I can't believe you designed for that to happen. And it's like, no, like, no one in C# language design said, man, we really got to make the Buffalo problem work with async.
Oh, that's true.
Instead, like, the way we generally approach this in kind of C# language design is, like I said, we were like, how do we make this feature as usable as possible while also having the maximum upgrade compatibility with people? It's evil people like me who sit back in language design and said, man, what bad things can I do with that? And part of that is, like, I'm the C# compiler lead, as I mentioned. Like, I'm kind of the front for a lot of user bug reports. And so we do get lots of bug reports and people kind of upgrade to new version of Visual Studio and C#. And if they hit a backwards compatibility issue where we weren't as backwards as compatible as we intended to, via a bug in the compiler or maybe a deficiency in design, like, I get these bugs. Like, I'm the person who generally sees these bugs at first and kind of moves forward. So I see the people who happen to name classes keywords that we eventually moved into, or people who are trying to take the language to like its furthest extent. And so I get to see much more mundane versions of these problems where someone has done something like this and they kind of hit a bug. And sometimes that inspires evil ideas for me to think about in my Twitter feed. But so, yeah, we don't design for things like this.
But isn't it true that originally, like, I think task was hard-coded, like you had to return task, and then we allowed for task-like types with the builder pattern so that we can actually do things like value task later, right? So it was not over-engineering on our end, right? It was basically, oh, we have this request, so let's make that work, right?
Exactly. So they vary when I believe it was C#4 is when C#4 or 5. 5 is where we introduced async and await. And I believe and at that point, while we did support kind of flexible awaiting, if you awaited something, we did have some flexibility in like the task you used. We did not have flexibility in what you returned. It had to be task or task of T. And the reason for that was we actually wanted to have task-like types from the very start. Unfortunately, it produced some very interesting overload resolution challenges and type inference challenges, and we couldn't get those done in time. So we kind of hard-coded task and task of T in C#5. But by C#7, we've gotten a lot more comfortable with kind of the mechanics of async and await. We took a PM, we locked him in a room for 3 weeks, and we told him he could come out again when he figured out how to fix the overload resolution problems. And he came up with a very elegant design of how we could solve all the overload resolution problems and have flexible task-like return types. And we added those in C#7. And you are right, the motivating factor is we wanted to add value tasks because there was a lot of performance benefits from doing that. But rather than try to say, hey, we're going to hard code a third type of task here, we said, no, now's the time to make it flexible. We fit the user case where they said, no, I want to plug this thing. I want to add my own behavior here. And we said, now it's time to really kind of sit down and solve that problem.
Somebody in the chat has to run this, but this is not actually a runnable program right now. We're not doing anything in main. So this is legal C# code. Do you want to set it up to run? And what would happen?
It's a no, but it probably just prints nothing, right?
Let's see. New var. we got to get this as far. Var v equals new. Have fun with that.
Oh my God, Jared, that's just evil. Like var meaning actually both var and var.
Yes. Well, let's see. Okay, I can't make. What? Oh, it's got to be async int because it's a. We don't allow that. So it does not ref. So my builder actually has like
Start simplifying.
Yeah, my builder simplified instructions. We could probably see how far we can get it. But
Yeah, but this is really just a point of it's some of the places you can go down, and that they're not like an oversight, like we're not paying attention. It's that we made a decision that and VAR was like the one that's easy for us to remember because there was explicit community discussions around whether the type VAR should become illegal. And this is the road we go down when we say that we're going to do this backwards compatibility. Now, we did one little tweak to this, which is that starting when we have a warning wave that says that if you have a symbol name, which is, Jared, help me get this right, is all lowercase, then it will, and we use it as 2 words, then we will not worry about stomping on you. So because that is just against. I mean, we'll worry about it if it's like huge, but we will generally think that it will be a very niche case that you are ignoring all current type symbol definition names.
And so if you hover here, you can actually see there's all these little kind of like diagnostics on the window here. And you can see if I hover over it, it's like a naming rule violation. Like these must begin with uppercase characters. This is both a naming rule violation and also, I believe, if you target .NET 7, if you target like a .NET 7 app, we actually make it a compiler warning. And as you said, the reason why is because we want the ability to use what we consider keywords, an identifier with all lowercase things, to further the language and make the language better without having to worry about all of this. And the reason this actually came about is records. So records is a case that finally broke our compatibility brains. So like, let's talk about like a record. So if we have a record in C#, we have record R and X and Y. So this is like a nice simple record in C#. Right?
And it's a nested record right now.
Yeah, it's a nested record inside of VAR.
I just want to point that out to people that might be a little confused by its location in the file.
Let's be real here. Let's do this correctly. Let's keep the theme of messing with people here. We're going to have the record dynamic, which is nested inside of VAR.
So it's a record named dynamic.
Yeah.
With a lowercase d. You're already a really bad person, Jared. This is already not good.
I know this is bad, but this is kind of the case. Like if you ignore the dynamic here and we do something like more reasonable, like R, this is a case that actually broke our like compatibility challenge in C# language design. So I'm sure 99% of people look at this like it's a record. Like what's the problem with this? Well, if we think about this from a compatibility perspective, what had happened if someone had said class record?
Jesus. No.
So this is now, if you think about this from a compatibility perspective, this is a completely valid method. I mean, I don't have a return type in here. I haven't thrown anything, but this is a valid method signature. Even if you do kind of the short form, if you do a semicolon, well, that's fine. If this is an interface definition, that would work just fine. Sure, it's a semantic error, but parsing is fine and easy to do. And this is a real problem for us because there was no way, like this is the record syntax that we really wanted to have. We wanted to have record name, like signature list. That is like the concise definition of records that pretty much every language out there uses. Like they have this nice, concise syntax for it. But if we wanted to be completely and totally backwards compatible in C#, and we want to have the record syntax, like they were not compatible goals. Something had to give. And what had to give was, we said, we will no longer allow record as a type and a return type position. If you put record there, we are going to interpret it as the keyword record. Now, if you wanted to keep doing this, you could basically use @ to escape and say, no, I don't want the keyword behavior. I want the other behavior. And if you want to keep your record, that's fine. This works just fine now. Don't throw an although. We were really, I mean, honestly, this might seem kind of like a triviality to some people listening to it, but we take this like very seriously. Like we were extremely worried, like, would we break big customers who had taken a huge investment on having a class named record? Luckily, this actually turned out to be a big nothing burger. This impacted pretty much no one. We made the change. It was very successful. We got the record syntax we wanted. We didn't upset any customers, which is great. But at the same time, we looked at this problem and said, we don't ever want to have this again. And we want to give users a warning that in the future, we may take over some lowercase type names and start using them as keywords in certain contexts. Now, we will still not like record is not like a full keyword. Like you can use record as an identifier and it is just fine. Whereas you cannot, for instance, use int as an identifier because it's a full keyword. But as Kathleen said, the way we have dealt with this is starting, I believe, in .NET 7, we will warn you if you have a type name which is completely lowercase, and just basically say, hey, if we decide that's a contextual keyword in the future, it might break a few of your use cases. You might have to come back and fix that by using @ if you want to kind of continue down this road.
Yeah. Hey, Jared, we have a couple of roadmap questions in the chat. And I just wanted to, I think, make a comment that we're probably not going to cover a lot of roadmap things right now. And the reason is that where we are in our cycle is that we're doing a lot of thinking on that. You can follow it. If you just search for Roslyn feature status, those 3 words, you should find our page where you can keep up with us a bit and our notes from our meetings. But I don't think we're going to cover that much today because, like I said, this question on DUs and primary constructors, and we just don't know right now. And so the whole roadmap stuff, also there's a question on roadmaps for generators. We still care about generators. We're still evolving generators. And one of the things on the roadmaps is docs. It's been really difficult for us to get done. We know that that's a whole. So at any rate, I just want to let people know if you came for roadmap, that's not really what we're covering today. And maybe Jared or Immo want to add something to that. But other than that, we can get back to the that question about this backwards compatibility. I would like to get back to that question. But first, do either of you have a comment on the fact that we're just going to kind of wait a couple of months before we talk about roadmap? I'm hoping it'll be by March that we can start having a conversation about C#12.
Yeah, I think March is when we'll have a better idea. At this point in our planning cycle, we're really focused on a lot of working with our partner teams, making sure we're doing everything to kind of support the upcoming .NET release and getting okay, what do we need to do to make sure these big kind of initiatives are settled? And that helps us often settle the big things we're going to do, the kind of non-compromisable things, we really need to get this done in the language or the compiler, since they're 2 kind of separate entities in order to make the next version of .NET successful. And as those kind of lock down and we get a little more settled in the big rocks, then we start kind of okay, how do we fill in all of the time remaining outside of those? But I think by Feb, March, we should have better ideas on a lot of those. Yeah. But as always, if you follow the language feature status, that'll show you what we're working on in the compiler team.
Yeah, and we use that really extensively internally. The folks that are doing that have done. We really tightened it up in the C#11 cycle, where that's actually the driver to get things into docs. And you should find early docs. We were in pretty much on with the release of the preview, thanks to Bill's great work. So our goal is that we will document features as they go into the preview, and then we'll pull them out if we get bang bang operator. We did remove that when we removed the feature. So we're going to take that risk of doing work that we might not need. And as soon as the feature we think is shipping, then we're ready to go. Now, on the question that's up, which I do think it's worth talking about for a minute, I mean, we do have a feature out right now where we are stressing over this. And, it's the field keyword, which I'm sure that's feature status, so it's no secrets on this. And so, yeah, we do stress about this. And is there a place we put less importance on it? I'm not going to say we ever don't stress about it and talk at length about it, because we do, I think, probably always consider it in some depth. We may decide that we're still going to grab a word. And that's, we haven't made that call on field yet.
Yeah. As Kathleen said, field is one that backwards compatibility has been a huge concern for us. So if people aren't familiar, one of the things that we were looking to add into C# this last time around is we were looking to add third prop. I'll not confuse people since I'm doing too long.
I was going to say, please don't use that silly type silly type you created. Yeah.
If we wanted to say non positive, if we want to say we have it at the positive value, where we wanted to basically today, if you wanted to write this out, you'd have to say int value, and then you would say get returns value, and set, you would say kind of if the value is less than 0, throw our given exception.
I think Jared needs Vim mode in this browser.
Yeah, probably. Honestly, I probably just need to turn off intelligence sometimes. And then you'd say like, okay, then, if it meets the thing, value equals value. So a lot of people, like, this is a very common pattern in C#. You'll see people who do this frequently. One of the actually biggest requests we've had from users is they hate the fact that this field is available, because this is a field which can only have a very narrow set of values, can only have positive numbers in it. And they want to even hide this from the rest of their class. They want to say, no, I don't even want the opportunity to make a mistake by having some part of my class accidentally directly assign value. I want to make it illegal to access this. It's an implementation detail of this property. Why do I have to make it available to everything? And so what we've had various parts of the ideas and design, like maybe we could allow you to declare like a private field that was scoped to the property or things like that. But the design we actually really wanted to implement in kind of C# 11 was we wanted to say, hey, for every single property, if you use the keyword field inside of this, we will just basically generate a hidden field of the same type as the property, and we just let you access it here. But you cannot access it outside. If you use field outside of this property, it means something completely different. And it's fine. Like it doesn't matter. Like, and this gives users what they wanted. It allows them to have a field which was scoped to this property that couldn't be accessed elsewhere. Unfortunately, this is a bit of a problem because, as I've kind of done before, what if someone said field?
And an important point here is that follows our the recommendations for naming. So the whole thing about types is that if you name something lowercase, you're out of the naming guideline. We're okay saying, look, you're gonna have to do something different. But here, this is normal. This is normal, and it turns out that the word field is applicable in some domains. If you're doing clocks, if you're doing magnets, if you're doing a whole bunch of things, field is a reasonable thing to have.
Yeah. And what even causes even more problems here is, like, this is actually very solvable. Like, this particular problem, it's annoying, but we can solve it. Like, we can go through, we can bind, and we can say, okay, fine, like, field, was defined here, and it's accessible, because it's not necessarily that field has to be something in this type. This could be a nested type. It could be defined in an arrow type. It could be a static. It could be something with a using static. There's like a lot of different places it could come. This is solvable. It is annoying, but it is solvable. It is the type of thing that we often say, like, we're making our life more difficult. Yes, but we're doing it to make the customers' lives better. What becomes very hard to solve is the opposite problem. If we suddenly basically say, like, whatever we want to do here, if value equals null, throw null, otherwise like value field equals value.
Don't throw null, but yeah, you get the point.
Yeah.
That's okay. You can throw null. You do bad things.
The fastest way to throw a null reference exception is to throw null, because the runtime will just throw a null reference exception for you. Much easier than, like, it's so many more keystrokes to say throw null reference exception. Just throw null. Much easier. The problem is here, one property that we have with structs is you can take pointers to them. Like, if you want to get like very unsafe, you can do things like, say, like, basically we can do, like, let's do static void people, and say it's unsafe. Something we basically allow you to do is have pointers to structs. Like, this is something that's kind of a little more esoteric C#, but it is something that is done quite frequently. Well, in order for us to take a pointer to type, we have to basically know, does it have any managed fields in it? Because we don't allow you to take pointers to types if they have like an object reference or a string or something like that, because that would be a recipe for GC holes and kind of GC madness. And so we don't allow it. Today, that's done by, we basically take a struct, if you want to, like, take a pointer to it, and then we go and basically say, hey, what are all the fields inside that struct? let's see what they are. Let's see, what their types are, and basically go through that calculation to see if it's a valid managed or unmanaged type. Well, once we have field-based properties, in order to basically know if this type contains any managed references or not, we have to go and bind every property in the struct, because we have to see if this uses a field keyword and it's using it as the implementation detail of prop, well, now this actually has a field of type string. However, if I had int fields, not so much anymore. This is actually not a backing field of the struct. And we end up actually in this binding loop. We end up in this kind of cycle of binding where we're basically trying to bind this type, see what its fields are, then we start binding the properties, but to bind the property, we have to bind this, which means we have to, and then we loop, infinitely loop. And this actually is an incredibly difficult problem for us to solve. And it is the reason we did not ship field back properties in C# 11. We found this problem very late in the cycle. We didn't have the resources to kind of fix it. And we've kind of moved this into C# 12, where we could discuss hey, we need to basically evolve our back and path strategy so that we can implement this feature in a reasonable way so that we can have nice, awesome usage here.
And I think there's a bigger problem with this, which is if you go back down to your public class var, which is, evilly named and all that, and you add a int that is a value, okay? So now today, if you go into that setter and you say you touch value, okay, you are using the value that is passed to set. You are not using that field. So if you want to maybe highlight them or something to make sure it's clear what I'm saying, and I am incredibly concerned that a few years from now that we're going to go, what? That visibility and who overrides what is different.
Yeah,
which one we see is different. If it's field and value, but field and value are almost exactly the same thing, the way that anyone is going to think about things down the road. And so it is that is the reason this is giving me a lot of pause. A lot. I'm thinking more about than you would like to think.
Yeah, it's definitely something that is when we talk about when users ask when does your strict adherence to back and pat become a problem? This is a great example. A lot of the times our strict adherence to back and pat causes what I would call more annoying problems. It forces more work on the compiler team or more work on the language design team to just kind of find creative ways to eliminate the holes. These are cases with field back properties where it's we're not sure we have a good answer yet. And we spend a lot of time looking at this. So this is one I think that we are really, really interested in shipping. And I think it is one that'll challenge us to evolve our back and pat strategy to make it more amenable to having easy to understand features that do what users want to do without bending over backwards for the minority of customers who decided to name their values this way.
Sorry, I'm a bit confused. I'm not sure you actually answered the question, because the question was, when are you going to stop caring? And you're basically saying, well, the caring isn't necessarily the problem. Some of the problems are just fundamental in the way the language has to work. So are you saying that our biggest problem isn't necessarily the backwards compat, it's just the problem of getting the semantics to the state we want? Or are you saying, well, we might actually do the backward compatible breakage at some point?
Yeah, we may work on this.
Right.
We've work on field. Yeah, it is absolutely possible that we will make it so that field inside a setter, and there are some weird cases where that will be a breaking change, which is a darn shame, and we're not going to do it easily. And will we ever get to a point where we do that casually? I don't think so. Will we get to a point that we worry less about types? Yeah, we've made an announcement, and there's a warning, and we want to discourage you from having types that are all lowercase, because this is a great question. Can we reserve the keywords? I don't think we'd be very good at it, and we would have to get a massive number. If we sat down and just brainstormed all the things that someone in the LDM thinks is a good idea down the road, that list might be longer than you want. And so right now, in terms of, we rarely have this problem where we're conflicting with a field. We're generally, historically, have conflicted with types. And types, we think we kind of have set aside. So this one, yeah, we could run across this again. We just don't really think we will, because it is kind of hard to conflict with a field.
Yeah.
But aren't you in a sense doing that, but basically saying that if it's lowercase, don't use it as a type name because it might conflict with keywords in the future, right?
Yeah, that one we definitely pushed on and said, yeah, keywords, type names, like you lowercase type names, like we really need to, we know that's an avenue for problems, and we have a diagnostic now to help people stop that. Now, I do want to clarify one thing Kathleen said, like she's right. Like we are looking at ways, like, can we break things in order to get out of these? Like we have thought of ways to solve this problem, and we just don't like any of the answers because they create other like things. Like Kathleen said, we can do some really crazy binding tricks to make this work, but then you end up with field equals value doesn't actually mean what you think it means. Like you're actually like you're using field from one place and value from another, and it's very obtuse. Now, what we won't do though is like we wouldn't say like, hey, you wake up tomorrow, I upgrade Visual Studio, and oh my God, field doesn't work anymore. Like no. What we would do, we would be tying it to some user action. Like, hey, in C# 12, 14, whatever, we decided to like put some restrictions on field could be used in very specific contexts. And if you move to that version of C#, then we would start giving you diagnostics, or there would be some user action where you said, hey, I want to start taking advantage of this new behavior. And we'd say, okay, here's a small thing you have to do to fix like this little very minor part of your code base. But that is kind of the general mechanisms we're looking at. Like if we started breaking things when people got new versions of the SDK, my life would be terrible because I'd be listening to like people emailing me every day that we broke things. So that's not something we would do. It'd be much more a user action of I want some kind of new behavior. And we would say, okay, here's some way of helping you understand like what we need to change to make that work.
Yeah, and this comment by Mocha, I'm sorry, I'm not sure about that. Yeah, that's the general idea that we're thinking about it, and we don't have it nailed yet, and we're not sure we're going to do it. But field has made it something we're talking about now, and that's what came up as we were talking about this whole compatibility question, because it really is something that drives a lot of our thinking. And I know anyone who understands how much time we put into language design is probably shocked, because we put an incredible amount of time into language design. And the reason is that we can't get blindsided by these. We have to see them coming. And then we have a lot of opinions, and we are, we're a collaborative group, and it takes some time to work through these, which is why, I could tell you that there's people that have opinions on discriminated unions and how we should build them right now, but do we know what we're going to do? Absolutely we don't. And we're ways away from figuring that out. We do hope that we will be able to provide a discriminated union solution, but they're different in other languages, and we have to figure out the right thing to do for C#. Yeah, it's just like, what do you mean? You want discriminated unions? What do you mean? And that it just puts us in a tough spot. But yeah, the backwards compat question is one that we will never stop thinking about backwards compat. Will we find ways? There's things here about maybe we should start obsoleting some stuff. Maybe we should do some other things. Our commitment to all of our .NET languages is that when you write something, yeah, it's good. It's good. Now, we can't make the same commitment for the platforms you use, such as the UI platform. We can't make the same commitments for the libraries for some good reasons, some of which they become unsafe even. But for the language itself, we do have a commitment that when you write something, it's going to keep working. Now, does that mean it's going to keep working in every future version of C#? Not quite. But we try to really minimize and help you through any changes that we might have to have to keep the language alive. Hey, boy type, let's do it. I don't think it's going to happen, to tell you the truth. And Immo and Jared are better than I to discuss all the gnarly details underneath. But as somebody who programs in F#, darn, it's just really too bad. But we don't have a unit type, and if we did have a unit type, backporting into things like task would be really tough. So maybe Jared has an idea. Maybe I'm wrong. It's easier than it looks.
I mean, I tend to think that the ship for a unit type kind of has sailed, but I would love it as well. Like I'm kind of annoyed that we have this weird split in the runtime between these things, but that's unfortunately the place we maneuvered ourselves into, right?
Yeah, particularly because we don't have a way to have any generic groupings. So we have if we have a func and it's func of T1, oh, we also need a func of T1 and T2. Oh, func of T1, 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 T2, T3, etc. And we go to maybe 7, and then we do some sort of fancy, slower thing. We do something like that. We just have to repeat the whole freaking thing for action. And this is, it's just a nightmare if you need to do something like that.
Well, that cuts it even deeper, right? I think delegate types should have been structural, identical anyway, right? The fact that they're all incompatible and you have to kind of agree on the delegate type is another unfortunate design decision that we made earlier, right? But that's at least now the natural type for lambda expressions in C# is action and func, right? So it's at least you have to do less typing to get to some sane world, but it is a problem when you compose different libraries and they have different opinions on what delegate types to use, right? The good example is func of bool func of t, bool versus predicate, right? Like that's a very common one where the BCL started with predicate and then eventually we just moved to func t, bool everywhere else. But
we definitely, even in the language now, like action and func are absolutely the canonical types. So when in C# 10 or 9, so I sometimes lose track of the versions, we allow you to define lambdas with var. So we allow you to basically say things like var func equals 42. And there's not a well, we do if you actually are not a jerk who defined var as a type. By breaking my demo here. Now you can see when I hover over this is defined as func of int. And what we basically said is kind of like going forward, like func and action are our canonical types. We allowed var-based lambdas, and we allow var-based lambdas, like we will use action and func as appropriate. And so while you can have, like, I agree, it would have been nice if they were more structural from the start, but they're not. But we're kind of making them as close to it as possible by really standardizing on top of action and func for everything.
Right. Now, once you start using ref, it becomes annoying because now you generate one type, but yes.
Yeah, we start using ref structs and ref, then we have to get out of the canonical based items, but that's a whole other ball of fun.
We have a question in the chat. I can't find it. If you can, there's that one. There's a question about C# 13, and my serious question is, can you tell me in the chat why you care? We do not know. It is probably, we haven't started asking, and if it's something you really care about us doing early, let me know, and I'll push on a little bit harder. But
I think they're asking, are we going to skip 13 and go
exactly?
straight
No,
to
that's
14?
exactly the question, and I want to know why you care. If there is a reason we need that decision made early, I figure that's a decision that we'll start pushing on maybe next summer, because we need to know by November for sure. But I'm not sure that we need to know a whole lot before then. But if you have a reason you care, then please let us know, and we'll try to push that decision a little further forward. Microsoft has skipped a lot of 13s. And will we skip this one? I have no idea. I have to go find the people that said we should skip some other 13s and ask them what we should do. It's just a number. I get it, Jason. I'm not gonna push back on that. But it's not me. And apparently some people at one point saw that as a cultural issue. So I'm not sure what we're going to do. Oh, it hasn't been a dad joke. Jared, you're falling down. What's wrong with you?
I just put it in there. Do you see what I'm doing here?
Oh God, that is so bad that it's okay, I guess.
You got to say it out loud or something. Or we got to put it up.
I didn't want to interrupt. I saw the thing go by, so I just wanted to have fun with it. But yes, do you see what I'm doing here?
I didn't. I don't see your dad joke. Oh, you put the dad, you put it in there. Where is it? I don't see it. All right, that's okay.
It's the do you see?
I'm sorry, I don't know where I'm looking.
Look at the comment.
I don't see anything in the comment. Am I looking at the right thing?
It's on screen right now. They can see it.
See the stand-up description?
Nah, no. If you look at what I typed in the code, there's something I typed.
I don't see it. Yeah. I don't. Just.
She doesn't see it.
It's been a long time since I've done C. So yeah. So anyway, it's all good. It's all good. So I tell you what, we've got about 10 minutes. So I absolutely think we should get some questions answered if we've got any more. Roslyn source generators. We're going to continue to evolve Roslyn source generators. Who did that come from? That's great.
Yeah.
I do have a question. If you're using Roslyn source generators, can you tell me that in the chat? And also, can you tell me if you're using V1 generators or incremental generators? Mostly, I want to find out if there's people using incremental generators, for which I have some respect because they're a little hard to find docs on. But yeah, so I'd love it if you could add that to the chat.
Yeah, in terms of roadmap stuff that we're doing, a lot of what we're doing kind of in the C# 12 timeframe is we're doing a lot of work in Razer. So Razer, the way the Razer language is implemented now is with a source generator. Razer is an extremely complex transformation in order to get from the kind of CHHTML or Razer files into both kind of your HTML and your actual C# code. It's a pretty interesting transformation, and they do a ton of work, and they do it all in a generator. It is, of all the generators that we monitor, it's probably one of the more complex ones that we have. A lot of our work that we're doing kind of in C# 12 is working on that generator as kind of an example for, we know as generators get more complex, they start kind of drifting in this direction. And so we are working on kind of APIs and tweaks to make that experience a lot better, fix some what we know performance issues and how that compiler works. And also it's a way for us, we're using it as a way to look at how we could get design time artifacts out of Razer available kind of for IDE purposes, because there's a lot of intermediate work that the Razer source generator generates and then kind of throws away because it has no way of exposing it. And so a lot of that is looking at the Razer source generator as a way to say, we know generators drift over here. Let's try to formalize this out, fix some problems over here, and expose it out. That's one of the big items that we're working on for kind of the C# 12 timeframe. There are a couple other smaller tweaks that we're looking to get done. We have a couple smaller requests that we're looking at, but those are kind of the big ones we're investing in for C# 12. And also kind of slowing down a little bit and letting people catch up.
Let me bring this up, because if I understand this question, it's pretty important. Wait.
That was a good one. Okay, we can go back to that one then.
I can go back to that one. I don't know which one actually went on, but yeah, this one is. Yes, they will be. What you mean is, will they be tied to Visual Studio? The answer is yes. We will. I don't know which version of 2019 you're looking at. They will be version specific of Visual Studio. The reason for that is they're compiler dependent. So when we add new source generator features, they're added to the SDK, to the C# compiler, and we can't get that downported into older Visual Studios. Jared, you can comment further on that.
Yeah, I mean, it's a lot of times so generators as a compiler feature are frankly very boring. When we did iSource generator at the start, hey, let's give them a compilation, get some files back, compile. We can do that, and we can do that really fast. Command line bash scenarios, we're good, no problem. The hard part about source generators is the IDE experience. How do we make it so that on every keystroke, Visual Studio is responsive? We are generating the code you want to generate. We are giving you intelligence based on the code you want to generate, based on changes made in the document. That is an extremely challenging problem. And the bulk of the work that is making sure to give you a good Visual Studio experience. So it's not even just that we have to put this in the compiler and we have to put this in the SDK. We very often, as we implement features and generators, we have to update the IDE to make it great, to expose it. We have to show you the analyzers and Solution Explorer. We have to make it go to def work. We have to make sure the ENC and the debugging, all that stuff is work. And that's why it's so hard to backport. It's not backporting a compiler feature. That's boring. That's easier to do. It's backporting an experience. That is significantly more challenging. And that is why it is generally tied to the newer Visual Studio versions. It's making sure that you have that great user experience about it.
And what came up that you wanted to come back to?
What modern languages designing modern C#. And the answer is all of them. All of them. I have a language polyglot. I love it. I run, one of the teams I run at Microsoft is kind of a Go utilities team. So I do a lot of Go. I cut my teeth in functional programming in F#. I look at that constantly. I enjoy looking at whenever one of the kind of subsets of the C# language that I kind of maintain is our lifetime safety rules, how we do refs, how we do ref fields, how we do ref structs. yes, I look at Rust from time to time to see like, hey, how are they like solving this particular challenge? Like we know that like lifetimes come down to very specific sets of problems. Like Rust is probably the most advanced at it. Like what approach did they take to solving this problem? Can we learn from it? Can we grow from it? Can we make our feature better by seeing it? And basically I look at pretty much all of them. Like kind of the big inspiration I'd say right now is I look a lot at like F#, Go, Rust, Java. Like I look at tons of different languages and just say like, what are they doing? What is making them awesome? Like, what did they do that was like really successful? Like, oh, that looks cool. Like, could we make C# better if we did that? Or, hey, we're doing like when we did records. So when we did records as a language, I spent a ton of time personally going like, hey, let me go look at all these other languages that did records. Like, how did they solve this problem? Let's learn from them. Let's see what they did and see if we can kind of integrate the things that they did well and put them in our language. And also, most importantly, when I'm looking at a feature, I often will take whatever the feature name is and Google like pain, errors, like confused, and find out like what do users not like about that feature in that other language? Like what is bothering them and causing them like concern? Are those like things that those language designers look at and say like, oh crap, I wish we had done that differently? Or is it just kind of an inherent problem of the space? And we try to learn from other people's mistakes and say, okay, they did this particular feature, they had that problem. You know, that seems kind of bad. A lot of users are upset about it. Could we maybe add a small tweak over here and just make it a little bit better for like C#?
And just one more thing to add to that. I just go across 3 languages. It's all I can handle. But what you're talking about is actually, there's a number of people that are on the C# language design team that are like Jared. And so when conversations start, we also have multiple perspectives on those different languages and how they do a particular problem. So, because we do talk a lot. We propose a lot and we talk a lot. So yeah. So when you say they've changed the type system so much, do you mean that TypeScript has changed the type system, or that I'm not, Jared, do you have an answer to this question as it's written?
Yeah, I'm trying to think of the best way to like say the answer. So like TypeScript, so if you look at like I'm not sure, like unfortunately I'm not as much of an academic, so I'm not gonna do like the correct words on like what type of type system TypeScript is as compared to like C# is a statically typed language. Like we're very statically typed, we're ahead of time compiled and to IL, but not to x86, but like we're a very statically typed language, we're very nominal. TypeScript is almost like a shadow type system. Like TypeScript is like type annotations at its heart. Like it is on top of JavaScript. Like when you say something in TypeScript is a particular type, you are not guaranteed. Like in C#, if you say, hey, this is string, it is a string. We know this. When you run that program, that will be string or it will be null. In TypeScript, if you say something's a string, or if you say something is like your little user-defined type, it might be that, it might not. Like it is TypeScript is an annotation. It's an annotation language. It is doing a fantastic job of establishing order on top of chaos and giving you type hints. It's giving you the semantics there, but it means that they can kind of like, I'm going to say this, and I do not want this to sound dismissive. This is just like, they can take kind of shortcuts in the corners. It allows them to be a lot more flexible with the rules that they use, because they don't have to like plumb this all the way through the JavaScript language. They can say that this is our type system, this is how we want, and we know that there's a corner here, a corner there, and it's fine. Because what we are focusing on is getting that high 90% code to work the way the user wrote it. Whereas in C#, like when we make a change, like to the fundamental type system, if we change how generics work, if we add like kind of a new IL opcode or any like kind of thing, we have to go all the way through the runtime. Like it has to go through C#, has to go every compiler out there. We have to change the runtime. We have to look how it impacts IL. We have to make sure all the JITs are going to do it. The AOTs are going to handle it properly. Like we are changing the fundamentals of the system. Where if TypeScript wants to do generics, like they're just kind of like having a system on top of JavaScript, and they're not fundamentally changing that runtime. They're not changing the fundamental type system that they operate on. They're changing that shadow type system they have on top of everything. Now, I will say that why can't we do things like TypeScript does? We actually did. If you look at how nullable reference types work in C#, it is exactly like the TypeScript system on top of JavaScript. Nullable reference types are not statically typed to the bottom. If you say If you turn on nullable reference types and you say string, that might still be null. Just like in TypeScript, if you say assert something as a specific type, it might be that type, might be something else. And so we have learned from TypeScript, and nullable reference types is one where we learned very strongly from them. And if you look at like how we made nullable reference types work and how like the TypeScript type system works in terms of things like if you assert something as a specific type, they will let you pretend it's that type for the rest of the thing. If you assert something as non-null in C#, we let you pretend it's non-null for the rest of the time. So that is one area like nullable reference types where we learned heavily from TypeScript, and we were able to implement a very similar type annotation. Let's get to the high 90% correct versus like 100% correct system. Is that a Lego in the background? Yes. This is an Imperial Star Destroyer Lego. This has been on my desk for let's see, about a year and a half. My wife got it for me as a birthday present. I had a lot of fun with it. It is enormous. I cannot figure out anywhere else in my house to put it, so it has just stayed here ever since. And we are, and this is really unfortunate because my wife has told me I'm not allowed to buy another giant Lego project until I find something to do with that. And I can't bring myself to take it apart. So I'm in a bit of a conundrum here.
So the one advice I have for you, never ever let it break apart, because I had the Millennium Falcon that broke in the middle. And I'm now at the point where the only way to reassemble is to take it completely apart and start from scratch, because I have no idea how I can fit it back together.
That would take sorting, and so that would probably.
Yes, it's much harder than when you do the set, because the set is bagged into like several sets of bags, so you only deal with a certain amount of pieces at a time. If you start with the entire set, it's a much harder assembly.
Yeah, I think I figured it out. I kind of like looked at it and I figured out an engineering solution where I could drop a few ropes from it and like hang it from the ceiling. I also have kids. The moment I put that on the ceiling is the moment they throw a baseball at it, and then I'm picking up pieces from the ground. So
you could also just super glue it, and then it's indestructible, right?
There's like thousands of pieces. That would take forever to super glue.
Yeah. Anyway, we have make sure I get this in before we stop. Is that if you'll if we have VB folks, enjoyers here, it's definitely I love VB. I love all three languages. I love their differences and I love their similarities, and I love .NET. So I'm definitely in that camp, and definitely I love the fact that you pointed out that changing things really often is not a good thing for everyone. And so Visual Basic, which is the language design itself, some things around it, and it continues to uptake C# features for interop in a consumption-only mode. So we do work on it. We are investing in Visual Basic, but the language itself is not changing. It is a more stable platform to work on, if that's what you want. If we make you crazy every time we change something, then Visual Basic has most of the features that you need to get your job done. Yeah, I will also tell you, as somebody whose kids grew up, that then you've got the problem with the very, very, very large bucket of Legos from all those different things you built along the way, that eventually you had no choice but rip them all apart, put them in a bucket, and they're still in my storage shed. So yeah, maybe one day I'll have a house big enough that I can have a Lego room and make my kids make Legos again, just as a matter of principle. So yeah.
That would be quite something. Alrighty, then I think unless you guys have something more that you want to show off.
I want another dad joke.
Another dad joke.
All my jokes are dad jokes.
I think Jason's joke about whether
because I'm a dad.
Does that count? We should think about it. I don't know if that counts. I guess it can count.
Yeah, we should ask ChatGPT some.
You have a dad
some
joke?
dad jokes.
Or I can close with this one. Do you know which of King Arthur's knights built the Round Table? Circumference.
Oh no!
All right.
Nice.
Dragonfruit, Mark. Dragonfruit 2.0. I'm thrilled you've heard the phrase. Yes, I am working very hard on that design. I hope that design will go public very soon. Soon will not be days, it may be weeks though. So I'm working very hard on the Dragonfruit 2 design. I am so excited about it and cannot wait to talk about it here on the stand-up in an upcoming month. But probably, I don't know if it'll be February. If you don't know what dragon fruit is, it's a CLI generator based on system command line. All right.
All right. Thanks, everyone.
Thanks you all
Thanks
for
for coming and
joining
seeing
us
this.
today.
All right. Have a great day.